Betelgeuse, a red giant star, is one of the most fascinating objects in our universe. If our Sun were in space, its size would extend to the orbit of Jupiter. This massive star is extremely unstable and close to exploding, making it one of the world's most powerful sources of radio energy. Betelgeuse produces more than 1 billion suns of energy. Its sheer size and obscurity have fascinated astronomers for centuries. Located in the Orion cluster, Betelgeuse has shown unusual behavior in recent years, such as a large image and strong vibrations, leading to speculation that it may soon explode in a supernova. However, there is also the possibility that we may witness a more terrifying event. Betelgeuse will collapse on itself. This collapse may have profound implications for the future of the world. Betelgeuse, 950 times larger than our Sun, is one of the most massive stars known. Despite its size is small, and it is a ticking time bomb. Located 650 light-years away, Betelgeuse dazzles astronomers who marvel at its brightness and seek to uncover mysteries in its fiery depths. Although we can see only 13.3% of its luminous intensity, if we were to see its full brightness, it would outshine Sirius, the brightest star in our night sky. Imagine a star 764 times the radius of our Sun that extends beyond the asteroid belt, close to Jupiter. In this great world, the Earth, Mars, Mercury, and Venus are covered by the shape of Betelgeuse. Every 1,000 years, Betelgeuse sheds a solar mass and submerges its remaining sky in a spectacular display of stellar theater. A nebula 250 times larger than the star itself surrounds Betelgeuse, shrouded in an opaque haze that obscures our gaze. This nebula is $30 and invites us to a cosmic dance, pointing to the discovery of mysteries. As the universe continues to expand, the approaching supernova Betelgeuse is a symbol of scientific curiosity and cosmic drama. This massive star, with its unpredictable behavior, gives scientists a unique opportunity to study the evolution of stars over time. This supernova event is considered a critical period in the life cycle of Betelgeuse, which may shed light on the final stages of the evolution of massive stars and the processes that drive these catastrophic events. The collapse of the core of a red giant like Betelgeuse can create many fascinating phenomena. As the star's nuclear fuel runs out, the core is bound under gravity, resulting in an increase in pressure and temperature. This process can lead to a supernova explosion, which pushes the outer layers of the star into space, leaving behind debris. Depending on the mass of the parent remnant, this remnant may become a neutron star or, if it is massive, collapse to form a black hole. Therefore, the Betelgeuse supernova is not just a sight for astronomers, but an important project for understanding the dynamics of such explosions. Supernovae are critical to the formation of elements heavier than iron, which are dispersed into space and contribute to the cosmic material that forms new stars, planets, and even life. The remnants of Betelgeuse's explosion will enrich the interstellar medium with these elements, continuing the cycle of stellar birth and death that shapes the universe. In addition to its impact on cosmic chemistry, Betelgeuse's supernova will provide a natural laboratory for studying the effects of such explosions on their surroundings. The shock waves from the supernova will interact with the surrounding interstellar medium, creating a pulsar wind nebula or a supernova remnant, depending on the explosion's characteristics. These interactions can trigger the formation of new stars and planetary systems within the nebula, showcasing the intricate relationship between stellar death and rebirth. Observing the evolution of Betelgeuse during its supernova progression reveals important information about the final stages of a star's life. Scientists monitor changes in the star's brightness, spectral lines, and other properties to better understand what happens just before the explosion. These observations are important for refining models of stellar evolution and supernova processes. The data collected will also help explain the differences in supernovae seen elsewhere in the universe. Considering the distance of the star from our world, the impact of supernova Betelgeuse on Earth will be very small. However, the event may have scientific and cultural significance. For astronomers, this is a rare opportunity to observe a supernova in a nearby star system, providing insight into the dynamics and consequences of the explosion. For the public, it is a major weather event that arouses interest in the planet and the planet. Cultural responses to astronomical events have ranged from wonder to myth. As Betelgeuse approaches, the last supernova will inspire a new wave of cultural and artistic expression, from literature to art. Dramatic images of a dying star and its explosive end capture the imagination of people around the world, continuing the tradition of celestial events that shape human creativity and imagination. In terms of technological advances, the Betelgeuse supernova observation pushes the limits of current astronomical instruments and techniques. Astronomers will deploy advanced telescopes and space probes to monitor the event, recording detailed images and features of the explosion. The data collected will increase our understanding of astronomical processes and may lead to improved technologies and methods of observation. The Betelgeuse supernova also serves as a case study to compare the behavior of various supernovae. By examining the characteristics of the Betelgeuse explosion and comparing it to other supernovae, scientists can understand the factors that influence the outcome of the explosion. This comparative analysis will help refine theoretical models and improve predictions of supernova properties, ultimately increasing our understanding of the life cycle of massive stars. In addition, the last explosion of Betelgeuse will serve as a reference point for future studies of stellar death and supernova phenomena. As one of the most anticipated supernovae, its observation will be a benchmark for future research and will help research into the final stages of stellar evolution. The data collected from this event will benefit future generations of astronomers and astrophysicists. The study of Betelgeuse and its nearby supernovae reveals a cosmic connection. The life cycle of stars, including their explosive deaths, plays an important role in the formation of the universe. By understanding these processes, we can take into account the formation and evolution of galaxies, the distribution of elements, and the potential for life in other parts of the universe. In summary, the Betelgeuse supernova promises to be an important event in astronomy and astrophysical research. The impending explosion provides a unique opportunity to study the final stages of a superstar's life and the subsequent effects on the surrounding space. As astronomers prepare for this spectacular event, the prospect reflects the dynamic and ever-growing universe. The scientific and cultural significance of the Betelgeuse supernova reverberates beyond the event itself, continuing to inspire and inform our understanding of the universe for years to come. As we dive into the heart of Betelgeuse's formation, we see that hydrogen fusion ignited, producing helium in a cosmic explosion. As time goes by, the star's hydrogen fuel is exhausted, and the helium in the atmosphere fuses with carbon, creating a glow that spreads across the universe. By combining neon and iron, it creates a wonderful transformation. The energy of the star, which has been released due to the lack of energy release, soon collapses, driving Betelgeuse to a sudden and catastrophic event, a supernova explosion. In the world of cosmic phenomena, supernovae rule, and Betelgeuse is no exception. With the power of 10 billion suns, this massive celestial body emits an energy that reverberates throughout the universe, surprising us with its unimaginable power. Over the years, stars go through a fascinating cycle, turning from the blues of youth to the fiery reds of maturity. In the 2nd century BC, Chinese astronomers discovered the yellow appearance of Betelgeuse, which was different from celestial instruments. Centuries later, the Roman astronomer Timarchus recorded the orange or red appearance of Betelgeuse. This situation always attracts our attention. The continuity of the color in various worlds, including to medieval observers in the Middle East, adds to Betelgeuse's remarkable performance. In 2019, Betelgeuse surprised scientists with a sudden decrease in brightness. At first, it was thought to be a large cloud of dust from the surface of the star blocking our view. However, the origin of this cloud is not clear. Some scientists believe that a larger object, such as a planet, has disturbed the star's surface or swallowed it. Recently, Betelgeuse has been about 50% brighter than its average brightness, an unexpected event because stars dim as they age. Scientists don't know exactly what causes this sudden increase in brightness, but they do know that a star's brightness can change for a number of reasons. For example, Some stars alternate between bright and dim phases, such as Mira, which is known for its brightness changes. Deep inside Betelgeuse, earthquakes occur. The explosion threw the flaming material into space, creating a magnificent cloud of dust that obscured a large portion of Betelgeuse's bright moon. This turned it from a bright light to a faint light in the night sky.